U.S. Office of Naval Research and the National Science Council of Taiwan under the Ocean Branch. And the IOP intensive observation period will be between 20th of August to 20th of October this year. We will have C-130 flying from US, and Chunjie will be flying with Dog Star, and more importantly, we will have 4 research ships. US research vessel, Ravel, Roger Ravel is already here. I'm going to show it to you. They are here. They are already here deploying a lot of mooring arrays and buoys, and we will have a lot of ocean observations during this period, as well as the atmospheric observations. So this is Ravel. Actually, my students set off just this Sunday. They are in the sea now. So I would like to share with you where they are now. Oh, internet is not working. Oh. Yes. Yes. Sorry.
Hopefully over the sea, not in the sea.
Yeah, they are over the sea. I will show it to you. They are over the sea. So this is where they are now. This is taken at this is where they are. This is where they are. Taiwan's here. They are right here. This is a live camera from the Ravel sending to the internet, so we can get to see the activities here. And this is the live camera here. Oh, this guy, yes. This is they are doing some observations here. And yesterday, I can show it to you. They deployed the donut, the big donut here. The buoy. This was last night when I was preparing. So this was happening yesterday as they were preparing it. And it was a very nice sunset with buoy development. And these are the yellow ones are the staff and the students. They are wearing the helmet and then to see the deployment. So we are going to install these moorings at the frequent typhoon tracks, and prayerfully, typhoon will went past these buoys for in situ measurement, and we would like to extend this work beyond sea blast, because in sea blast the wind measurement was only until 30 meters per second. So we need to have a better coefficient, CD, CE, and so on. So with so many super typhoons here, we are hoping to have these new observations through this experiment. So finally, I would like to conclude my talk. Firstly, I show it to you the strategic location of ocean precondition can have fundamental impact on intensification, for example, in rapid intensification, which will severely affect the subsequent impact on land. So we have to, and we give examples, Nargis. And the second point is that Morakot encountered a well-defined warm ocean eddy just prior to landfall, which, from the observation, we believe it will help. It helped this asymmetric convection development. And the third part is to share with you all Western North Pacific is a very complex ocean. And between 20 to 26 degrees north in this latitude, we have an eddy ridge zone, and they act as boosters for super typhoons. And between 10 to 20 degrees north, which is the MDR here, there are a lot of variability are observed due to ENSO, which can cause 40% reduction in the heat content. We are talking about 120 from 120 to 70 kilojoule per centimeter squared. But their impact is only on slow-moving storms, but not on the fast-moving ones, because the fast-moving ones can afford to intensify over shallow waters. And finally, for intensity forecast consideration, we need to consider the ocean precondition with respect to these changes, ever-changing ocean variability. And don't use just SST. This is really my summary. SST is really not enough. And when considering the ocean condition, please consider it with respect to the translation speed, because it will determine how much a storm needs. And lastly, I would like to acknowledge Mr. Udarong and Dr. Wang Yuqing for their help in commenting the Morakot work. Thank you.
the conclusion slide?
Yes.
In the beginning, you said obviously ocean is a necessary condition, right?
Yep.
So, which I agree, of course.
Yes.
So then my question is, when you say it's a booster for Super Typhoon.
Right.
So is that a necessary or sufficient condition?
Okay. Good. Let me answer from this slide here. So, because to make a super typhoon, you need to have energy supply all the way through the intensification processes. So ocean provides energy as a necessary condition. So the point is this: without the ocean being there, without the eddies being there, this is a bad ocean which will not be able to support intensification for a super typhoon. So I'm saying, of course, atmospheric conditions are good, okay? But with good atmosphere but bad ocean, you will not have a super typhoon. So with good atmosphere, you need to have sufficient flux, as it proved here, because this is clearly proving that even with super duper atmospheric condition, you do not have fluxes. How can you intensify to category 5? So this is necessary. Even with a Ferrari without petrol, it will run fast.
So if you go a step further, then have you looked at enough cases to say that whenever you have a category 5, that
right.
you would have a warm eddy?
Yes. Okay. This is the case.
I mean, you have the 2 cases there.
We have here. This is all the 8 cases in the 13 years. Okay. So these 2 cases are just an example. It's an illustration. So basically, this is a bad ocean for category 5 because not enough heat content. So the ocean itself will not favor for intensifying category 5. So the ones which pass here and make it to category 5 are the lucky ones, because those lucky ones has the opportunity to encounter the warm ocean eddy.
So my other question is, in the El Nino year,
Yep.
Have you looked at the cases where you, whether in an El Nino year where you have more intense storms,
Right.
Are these storms actually moving faster?
Yes, this is the fast moving ones. This is the one.
So these are all the cases that you have.
Okay, we observe this is the case in 97. Because the other El Nino, the shadow is not as drastic. So there's a difference in the El Nino. This is the most drastic El Nino. Yes. So basically we are saying that how much a storm needs